Welcome back. Today we're going to work on quadratic functions, which is section 3.3 in your notes. We're going to do this in two parts, so give you a little break, and if you want to work on homework after the first part, you're welcome to do that. If you'd rather fill in all the notes, you can watch the two parts together. All right, so most of you remember quadratic functions. They're second degree polynomials, which means the highest power is 2. Typically, they're written in this form ax squared plus bx plus c, and the shape of the graph is a U, which you guys remember is called a parabola. So underneath here, with all of this information in this box right here, I've separated it for you into two parts, depending on the form that you're given. So on the left-hand side, these are the things that you can get out of a quadratic function given to you in standard form, which is the form above that we just talked about. And then over here we have vertex form, and this is the information you can get out of this form. Both of these have the highest power of x squared. It's just a different way to write them. So over here in standard form, you have the vertex, which is to find the x coordinate, you do negative b over 2a. And then this just represents, remember, the y coordinate when x is negative b over 2a. Axis of symmetry would be x equals negative b over 2a. The y-intercept, if you're asked for that, is just this value c right here. And then how you know whether a function opens up or down, the quadratic opens up or down, is based on the value of a. If a is positive, it opens up. If this value here is negative, then it will open down. And then remember, the domain for any quadratic is all real numbers. And then to know the range, if your parabola opens up, then the range is going to go from the y value of the vertex, this value here, to positive infinity. And if your parabola opens down, it's going to go from negative infinity to the y value. Okay? Now, vertex form is a little different. Some things are easier to find in this form, and some things are a little harder. So the first thing is the vertex. Much easier to find because this is vertex form. Remember, the vertex is always the h value and the k value, okay? That's the vertex. Remember, h will be the opposite of whatever this sign is. Your axis of symmetry would then just be x equals h. The y-intercept you got to solve for, so you would let x equal 0 and then solve for y in that problem. Same thing for a, whether it opens up or down. That a value positive, it opens up. A value negative, it opens down. And then the domain, again, all real numbers. The range, if it's this way, will go from k to infinity. That's the y value of the vertex, just like over here. And then if it's going downward, then negative infinity up to k. Okay? So all of that is just a nice, easy place where it's all stored, all the information, so that you can get to it quickly. All right, starting the problems down at the bottom. Name the vertex and the axis of symmetry, and then write each quadratic equation in standard form. All right, so since these are in vertex form, then it's easy to find the vertex. Okay, so the vertex for part A in number 1, remember, is the opposite of what's in here, and then the same as what's out here. So that means the vertex of this parabola would be at the point 3, 4. And then remember your axis of symmetry, which I'll always abbreviate AOS. You have to write x equals, and then it's whatever the x value is. You can't just say the axis of symmetry is 3. That would be incorrect. It is a line, so you have to say x equals 3. Okay. Now we're supposed to take this and write this in standard form, so we're just going to multiply it out and do a little bit of computing with it. So the first thing we're going to do, let me rewrite it here, is we're going to square x minus 3. That's a foiling problem. So remember, that means x minus 3 times x minus 3. So I'm going to do it all in one step. I'll talk you through it. So first, x times x is x squared. Then you're going to do outer and inner. So it's negative 3x and a negative 3x. So in the middle, you'll get negative 6x. And then last, negative 3 times negative 3 is a positive 9. Okay. Next, you're going to multiply by 2. So 2 times x squared is 2x squared. 2 times negative 6x is negative 12x. And 2 times 9 is 18. And you got that plus 4 there. And then the last thing you'll do is add your like terms, which in this case is just the 18 and the 4 at the end, which is 22. So there's standard form. Here's vertex form. They don't look too much alike other than the 2 out front, because that's the only thing that's similar in both is the a value. But those two equations are the same exact parabola. It's just standard form down here, and this is vertex form. All right, so same thing for B. Find the vertex. It's always going to be the opposite of what's inside, so -1, and the same as what's on the outside, -2. So your axis of symmetry would just be x equals, and then whatever that x value is. All right, now we're going to take this function, write it in standard form. So same process. All right, so the first thing we're going to do is the power. So we're going to square x plus 1. Put that over here. Okay, I'll do that with you. So FOIL it out. X times x is x squared. Outer is 1x and inner is 1x. So that gives you 2x in the middle. And then lastly, 1 times 1 is 1. Okay, -2 at the end. Second step will be to multiply that -3 through all 3 terms in there. So -3 times x squared is -3x squared. -3 times 2x is a -6x. -3 times +1 is -3. And then add those numbers at the back. -5. Okay, so here is your standard form. And remember, this is the vertex form. So they are one and the same, just different forms. Okay. All right, on the next page, we're going to find the vertex and axis of symmetry of a function in standard form. Okay, and then also the domain and the range. All right, so this one's a little harder because the vertex is just not there. This is standard form. So in standard form, to find the x value of the vertex, you do -b over 2a. Okay, so -b means the opposite of b, so -8, and then 2 times a, the number in front of x squared, which is 1. So we end up with -8 over 2, which is -4. So that's the x value of the vertex. Now to find the y value, we're going to plug in -4 into here and find y. So we're going to find f of -4 now. So -4 squared plus 8 times -4 plus 5. So -4. Okay, so again, to find the y value, you plug what you just got for x in here for x and solve for y. All right, so that gives us -4 squared, which is +16. 8 times -4, -32, plus 5. So we end up with 16 minus 32. Got to do these in order. 16 minus 32 is -16 plus 5. So that's going to end up with a -11. So the y value of the vertex is -11. That's the x value. Find the vertex. So the vertex would be -4, -11. Your axis of symmetry is just, remember, the x value. That's the easy one. Just make sure you write x equals. Okay, so there's the vertex, axis of symmetry. Domain for any quadratic is all real numbers. And the range, okay, so we got to look at this parabola. It's going to open up. Okay, it's going to look like that. So the range is going to go from the y value of the vertex to positive infinity. Y value of the vertex is -11. So that would be the range. Okay. Okay, same thing for part B. We're going to find the vertex first. So we always start by doing -b over 2a to find the x value. So -b in this case would be a +20 over 2 times a, which is 2. So that is 20 over 4, which will give you 5. Take 5, plug it into the function to find y. So 2 times 5 squared minus 20 times 5 plus 43. All right, so that gives us 5 squared, which is 25. 25 times 2 is 50. Negative 20 times 5 is negative 100 plus 43. So do this in order. 50 minus 100, negative 50 plus 43 will end up giving you a negative 7. So the vertex, x and y, 5, negative 7. And the axis of symmetry is just x equals 5. Okay, that's how you do those. Domain is all real numbers, always. Okay, and then the range. Again, since a is positive, this thing's going to open up. So we're going to go from the y value of the vertex up to positive infinity. So that would be from negative 7 to positive infinity. All right. Moving on to a couple different kind of questions. Now we're going to find b and c so that y equals negative 2x squared plus bx plus c. So this time you're given the vertex. This is a little tricky question because it looks like this is standard form and that's what you'd start with. But anytime you're given a vertex, you want to start with vertex form. So we want to start with y equals a times x minus h squared plus k. Now we already know that a is negative 2 because they're always the same in both. Okay. And this, remember, the vertex is your h and k value. And always in here, the x value will be the opposite sign. So that gives us x plus 10, because it's minus a minus 10, right? So minus a minus 10 is going to end up being plus 10, and then k is 5. So now we're just going to take that like we did on the front and multiply it out. So we're going to FOIL x plus 10, right? X plus 10, x plus 10. So when you FOIL that, you get x squared. 10x and 10x would give you 20x. And then 10 times 10 is 100 plus 5. Multiply through your negative 2. Negative 2 times x squared. Negative 2 times 20. Negative 2 times 100. Right? 40 and 200. And then plus the 5. So add those last two numbers. So that's minus 195. All right, so now look, now you have standard form, so now you can tell me what the b and the c are. So b would be negative 40, and c would be negative 195. These numbers will get big sometimes, so don't think you did something wrong. As long as you follow the steps, you will be fine. All right, let's look at 4 and 5. We're given some graphs of the parabola. We're supposed to write the equation for the quadratic function, okay? All right. So, since we have the vertex and we have some points, we know we can find all of that. But what we're missing in both of these would be a, okay? So again, if I know the vertex, I want to start with this equation. Vertex form. Now, I'm going to show you, we have the vertex. Remember, that's h and k. And then you can use any point you want to. 2, 0 or 6, 0, doesn't matter. I'm just going to use the smallest one. So this is x and y. That's a point on the graph. Okay? So I gave you actually more information than you need. All right, so we're going to substitute in x and y, these two numbers for this x and y. Right? And then we're going to substitute these numbers in for the h and the k. So that'll leave us everything that we need except for a, and we can figure out what a is. So y in this problem is going to be 0. Right? That's the y value. Don't know a. X is 2 minus h, which is 4 squared. And then plus k. Since k is negative 4, we'll just do minus 4. All right, so we can work this out now for finding a. So the first thing I'm going to do is do this in here, the parentheses. Okay, so 2 minus 4 is negative 2, and negative 2 squared is a positive 4. And then we're going to solve this. So I'm going to move the 4 over to that side, so it'll become positive. And then a times 4 is just 4a. Divide both sides by 4, and we get a is 1. So then we can write the equation now. Okay, y equals, a is 1, so I don't need to put it. And then x minus 4 squared minus 4. Again, there's your vertex hk, right? And this is a form for your function. Now you could put f of x there, same thing. Okay, so that's the equation. So all we needed was a, and after all that, a was just 1. All right, so on this one, I have a feeling a is not going to be 1. So here's your vertex, so hk. Pick any point you want to. Okay, doesn't matter. I'll just pick this one. So there's your x and y. So we're going to start with this formula. Again, anytime you have the vertex, plug in your vertex numbers for h and k and plug in x and y. Okay, so y in this problem was 5. Don't know a. X is 0 minus h is 2 plus k is 9. All right, so we're going to work this out. So do the parentheses first. 0 minus 2 is negative 2 squared is a positive 4. We're going to subtract 9 over here. So 5 minus 9 is negative 4. And then that's 4a. Divide by 4, we get negative 1 this time. All right, so we'll write our function. Now, I'm just choosing f of x this time. Remember, you can use either one. They're replaceable. So the function would be a, which is negative 1, times x minus the h value, 2 squared, plus plus k, the y value of the vertex, which is 9. Okay? So basically, you already know this based on what you're given. All you're looking for is that. Now, they didn't say whether to write it in standard form or vertex form, so I'm just going to leave it in vertex form, and you already know how to change it to standard form if you need to. We've done that 3 times already. All right, foiling that out and then simplifying. Okay. Now we're going to talk about solving quadratics. All of you have done this before. You may not have done all 4 ways, but I know that you can do some of these. As far as I'm concerned, on your tests or quizzes, you can choose any way you want to. You just remember, need to show me your work, so make sure you pick the way that you would like to do. So there's 4 ways to solve a quadratic equation. And remember, when you're asked to solve, you're looking for x-intercepts, and there's lots of words that mean that. So I could tell you to solve the quadratic. I could say find the x-intercepts. I could say find the roots. I could say find the zeros, or I could say find the solutions. Every single one of those things means the same exact thing. So basically, any of those means where does this graph cross the x-axis? That's what you're looking for, okay? A couple of things to remember when you're solving a quadratic. You always have to have the equation set equal to 0, and you always want the x squared term to be positive. It's just much easier for you to not make mistakes if you do that. All right, so the 4 ways, if you remember any of these. 1 is to graph it. You find the x-intercepts using the graph. 1 is to factor. Okay. 1 is to complete the square, and 1 is using the quadratic formula. So we're going to do one of each right now. So on the first one, I'm going to do this one. I'm going to choose to factor. It's easy because it's an easy factoring problem. I'm going to do number 2 or number 7 by graphing. Now you don't have to do these ways. I'm just showing you one of each so you kind of can remember. Okay. Number 8, I'm going to complete the square. I would say that's everybody's least favorite, but I'll show you anyway. It's actually not too bad, but you guys don't typically like that. Okay. And then I'll do this one by quadratic formula. All right, so let's go back to number 6 and factor. So in order to factor, we have to have one side equal to 0, which it is. So let me talk about that right now and put this up here. You guys need to write this down. Remember, we've said that f of x is the same thing as y. Well, when you're solving, that is all the same thing as 0. Okay? So as long as you have y equals or f of x, then that side is 0. All the other terms are over here. So we can rewrite that as 0 equals x squared minus x minus 6. And then you're going to factor. So factors of 6 that subtract to give you -1 would end up being -3 and a +2. Okay. Then remember what it says up here. You factor and then you set the factors equal to 0. So we're going to set each factor equal to 0. And then you're going to solve each of those. So we're going to add 3 to both sides. And over here we're going to subtract the 2. So there are your solutions. Excuse me, for that quadratic function. All right, number 7 we're going to do by graphing. See if this thing will show up on here. Not too bad. All right. So we're going to put this equation into y equals. So we're going to go to y equals 2x. Remember, x is this button right here. That's where you get your x. So x minus 3. Close your parentheses. Squared is right here, squared. And then minus 5. So make sure it looks like what it does on your paper. Graph it. All right. Now, you can't just estimate these answers. They got to be exact. So we're going to use the calc menu, which is under trace. Second trace, right? Calc up here. So we're going to hit second trace. And then we want to find the zeros. That's where your x-intercepts are. So you're going to hit 2. And you have to do this 2 times. So let's find this one first. So you're going to be asked 3 questions. What's the left bound? What's the right bound? And then what's the answer, basically. So the left bound means just pick a spot on the graph that's to the left of the root that you're looking for. So I'm going to use my left arrow. Now, notice that I'm in the negative, so I want to go to the right. I want to see the little cursor. So this is telling you where x is. So there it is. So that's to the left of this point. So I'm going to hit enter. And now it's asking for the right bound. So take right arrow and go to the right of that, which would be somewhere over here, right? So if you look at this points to the left of my pen, and this points to the right of my pen. So I'm going to hit enter. All right, so put in a little boundary. So it's going to find the 0 that's between those 2 points. So it's asking you to take a guess. So this is not your answer yet. When it says guess, you're not done. You're going to hit enter one more time. There's your 0, 1.4188612. Now we can round that a little bit, so we'll say x equals 1.419. Let's go at least 3 places. Pay attention when you're doing your homework in Ox. It'll tell you how far to round it. All right, so now we have to find the other one. So we got to go through the same process. We got to start over. So second trace, number 2 for 0. Now we need the left bound, which this time will be underneath the root. So again, look at your root, and that cursor is to the left of where my pen is. So that's the left bound. Enter. Now it wants the right bound, so we're going to go above it. Doesn't matter where, as long as you're above it. Enter. And then remember, that's not your answer. Hit enter for the guess. It'll say 0 when you're done. So the other 0, 4.58, we'll call it 1. Okay? All right, so that's the graphing way. Okay. So there are your answers. Now, you could have just as easily have graphed this one and found those would have been your roots. Same way. Okay? All right, completing the square. So on this one, you don't have to have 0 on the right. This one is where you want the number on the right. So that's why I chose this for this example. Okay? If you're going to do it any other way, you would need to move the 7 back over to this side and make it plus 7 equals 0. Okay? But for completing the square, you want the number on the right. And then what you're going to do is you write the problem as a trinomial. So you're going to leave a space. Okay? And you're going to fill in what makes this number here, what makes this problem a perfect square trinomial. So the number that always goes here is half of the middle number squared. So if you take half of 8 and square it, you get 16. That is always the rule, and it's always plus, because any number squared is positive. So again, to find the third number, you take half of this number and square it, and whatever you do to this side, you do to this side. Okay? All right, so then you're going to factor the left, and that's why you do that, because it factors nicely. X plus 4 times x plus 4. Add the right side, which will give you 9. And now we're going to solve. So we're going to undo squaring by taking the square root of both sides. Take the square root of that, and we're going to take the square root of that. Okay? So square root undoes the squaring, so this side leaves you x plus 4. And the square root of 9, remember, is plus and minus 3, right? There's 2 answers for that. Okay. And now you're going to solve for x, so you're going to subtract 4 on both sides. So you got 2 things to do. You're going to do negative 4 plus 3, and then you're going to do negative 4 minus 3. That's why you're going to get your 2 answers. So let's break that up. Negative 4 plus 3, and then we're going to do negative 4 minus 3, okay? Because that's 2 numbers. So we got a positive 3 and a negative 3. So negative 4 plus 3 is negative 1, and negative 4 minus 3, negative 7. So there are your 2 solutions. Now remember, we're doing quadratics, so typically they have 2 solutions. Remember the square, that's how many answers you should get. Sometimes you'll get 1, sometimes you'll get none, but usually if they're not the same, you'll get 2. All right, last thing is the quadratic formula. So let's remember that. And the quadratic formula is just helping you find x, right? The solutions. So it's x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, hopefully you remember that. So here's a, here's b, here's c. It's already equal to 0, so we're good to go. So negative b means the opposite of b, so that's negative 4, plus or minus b squared, so that would be 4 squared, minus 4 times a, which is 2, times c, which is 9, all over 2 times a, which is 2. All right, so we just got to simplify that. Negative 4. All right, 4 squared is 16. Minus, and then 9 times 4, that's 36 times 2, 72. Is that right? 9 times 4, 36. Or we just do 8 times, yes. All right, so either way. 4 times 2 is 8, 8 times 9 is 72, all over 4. All right, so you can use your calculator if you need to do 16 minus 72. Doesn't really matter. Okay? So 16 minus 72, negative 56 over 4. All right, so right here, I know that I'm not going to have real answers. This is an imaginary number, okay? I'm going to go ahead and simplify that because you do need to know how to simplify radicals. So let's look at that, okay? So negative 4. Anytime you have a negative radical, I know that's an imaginary number. So I'm going to take out the negative 1. Then I need to break up 56 into 2 numbers, one of which is a perfect square, okay? All right, so 56, 4 goes into that, 14 times. So we're going to break that up into 4 times 14. Run out of room, so I'm going to put it all here. So this is negative 4 plus or minus. So now I can take out the square root of 4, which is 2. I can take out the square root of negative 1, which is I. So that's 2I square root of 14 all over 4. Now, these are numbers. So you're going to divide the denominator into both of the number parts. You do not divide a number into a radical. So we can reduce negative 4 over 4, and we can reduce 2 over 4. Okay? So negative 4 over 4 is negative 1 plus or minus, and then 2/4 is 1/2 I square root of 14. So that would be the simplified version. Okay? And if you look at this graph on your calculator, if you tried to graph that, it would be like way up here somewhere. So it doesn't cross the x-axis, so that's why there are no real roots. So I'm going to write that here. No real roots. Okay. So there's really no solutions to the graph, but there are imaginary solutions. Okay, so pay attention to your homework if it's asking you for real solutions or just any solution. Okay. All right, so I'm going to stop the recording here for this section, and then part 2 will pick up on the next video, and we'll complete the notes from there. So you can either continue with your notes or stop and do some homework so you're sure that you understand all of this information. Okay? As always, let me know if you have any questions.